Welcome to AI on the Edge, Machine Learning's Next Leap. In this episode, we explore breakthroughs in training, privacy, and multimodal artificial intelligence, spotlighting highlights from 64 leading-edge research papers published on July 1st, 2025. From optimization techniques to real-world impact, we present pivotal studies shaping the future of AI, all brought to you by AI Frontiers. Here is your roadmap for today's journey into the frontiers of machine learning. We begin with a concise field overview, addressing the essence of machine learning. Next, we identify the key research themes emerging from July's cohort of papers, followed by deep dives into foundational breakthroughs. We will examine the methods propelling modern AI and conclude with a future outlook, highlighting how you can engage with and influence this evolving conversation. Machine learning is the heartbeat of modern AI. It refers to systems that learn directly from data rather than relying on explicit rules. This capability powers applications across language, vision, healthcare, and beyond. The field bridges rigorous mathematics and tangible real-world impact, with research as its driving force. Every paper contributes to progress. It forms the essential foundation for both current and future capabilities in artificial intelligence. The first theme centers on the scaling and optimization of large language models. As demand for ever larger models accelerates, new and efficient optimizers become necessary. Zhang and colleagues introduce a stochastic conjugate subgradient method, enabling faster and more reliable training compared to traditional approaches. Liangyu Wang and team address the dual challenge of privacy and efficiency, presenting scalable, privacy-preserving methods for large models. The core challenge is balancing increased data and privacy requirements while minimizing computational waste. The key technical concept here is optimization, where smarter algorithms consistently outperform brute force methods. The second theme is privacy, security, and trust in AI. Protecting user data in sensitive domains is now a critical concern. Yang and collaborators have demonstrated efficient private on-device learning, ensuring that user data remains secure during model adaptation. Additional research focuses on defending against adversarial attacks and data leaks, alongside new techniques for secure model fine-tuning, particularly on mobile devices. Differential privacy emerges as a pivotal concept, enabling models to learn meaningful patterns without exposing individual data details. Theme 3 addresses the challenge of bridging modalities through multimodal and cross-modal learning. Artificial intelligence is being taught to connect vision, language, and audio modalities for a richer understanding of the world. Hyoseo and colleagues introduce the Joint Autoencoder Modulator, known as JAM, for explicitly aligning models trained separately in vision and language. Cross-modal learning enables more flexible and robust AI systems, with modular architectures allowing specialist models to collaborate. The overarching aim is to advance toward generalist, adaptable AI systems capable of integrating diverse types of information. The fourth theme highlights quantum, physics-inspired, and foundational learning. Quantum-enhanced models are beginning to unlock new efficiencies in machine learning tasks. Bara Rababa and collaborators show that quantum neural networks can outperform classical models, even in practical applications. Theoretical advances, such as Liu Ziyin's Platonic representation hypothesis, deepen understanding of how neural networks converge on similar internal representations. Research in this area often integrates physics principles with deep learning, with quantum learning representing the use of fundamental physical laws to guide AI development. The fifth theme focuses on real-world applications and automation. Machine learning is now being applied to sectors such as healthcare, transportation, and more, with a particular emphasis on robustness, interpretability, and practical deployment. Edouard Lansiaux and colleagues demonstrate that large language models can surpass human experts in emergency department triage. The field is increasingly dedicated to bridging the gap between research and tangible impact. Positioning AI as a reliable assistant within critical real-world settings. Across the 64 papers reviewed, several transformative insights stand out. Smarter optimizers, such as those developed by Zhang and team, enable faster and more scalable training. Privacy at scale is achieved through efficient and secure learning methods proposed by Liangyu Wang and collaborators. Modular multimodality is advanced by Hyoseo's work on aligning AI models for cooperative performance. Quantum AI sees early real-world successes, especially in work by Bara Rababa. Finally, large language models are now outperforming humans in healthcare decision-making, as shown by Edouard Lansiaux and Associates. Modern machine learning research delivers impact through a synthesis of advanced methodologies. Optimization goes beyond classic gradient descent, incorporating approaches like stochastic conjugate subgradients and AtomW for improved convergence. Differential privacy provides provable protections for sensitive data. Representation alignment, achieved through joint loss functions, enables effective multimodal fusion. Quantum-inspired modeling integrates physics principles for enhanced efficiency. Additionally, robustness, interpretability, and uncertainty quantification are prioritized to ensure reliability, especially in high-stakes domains. Today's featured paper is Beyond First Order, Training LLMs with Stochastic Conjugate Subgradients and AtomW by Zhang and colleagues. This work addresses the inefficiency of traditional training approaches for large language models by introducing a robust optimization method, stochastic conjugate subgradients. The algorithm utilizes adaptive sampling and step sizes inspired by AtomW, resulting in accelerated convergence. Performance evaluations indicate substantial improvements over standard methods, particularly as model and dataset sizes increase. This paper is highlighted for its fundamental impact on scaling artificial intelligence. A seminal contribution is presented in the paper PAE MOBI LMM, Privacy-Aware and Efficient LLM Fine-Tuning on the Mobile Device via Additive Side Tuning, by Xinke Yang and collaborators. This approach enables private and efficient model fine-tuning directly on mobile devices. The technique employs additive adapter modules and pivot tokens to preserve privacy, drastically reducing the volume of data transmitted to servers. Empirical results reveal that this method matches or surpasses the accuracy of existing models, marking a significant step forward in bridging privacy concerns and mobile AI deployment. Another influential work is Escaping Plato's Cave, Jam for Aligning Independently Trained Vision and Language Models by Hyoseo and colleagues. This research introduces the Joint Autoencoder Modulator, JAM, to align vision and language models using a combination of contrastive, negcon, and spread loss functions. JAM facilitates robust cross-modal representation alignment, even for large models trained independently. The aligned models outperform baselines on multimodal tasks, representing a substantial advancement in generalist and modular AI architectures. Looking forward, the next wave in machine learning will be shaped by several key directions. Efficiency and privacy are expected to influence model scaling strategies, while modular, interoperable AI systems are set to become more prominent. There will be greater integration of physical and domain-specific knowledge into AI models. Robustness, trust, and interpretability will remain central priorities. However, open challenges persist, particularly in balancing privacy, utility, and reproducibility as the field evolves. This synthesis was created through the combination of advanced AI tools and human expertise. Summaries were generated using OpenAI GPT 4.1 for language processing, while AI-driven text-to-speech and image generation supported the multimedia components. Every segment was reviewed by a human expert for accuracy and clarity, though the potential for oversight remains. All referenced papers are provided, ensuring transparency. This comprehensive review results from the synergy between AI technology and informed human judgment. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by Archive Preprint Server.